in this example, you just see one more example about the interfaces. So let's say that we have this interface transporter in which it has this void move function. And then if we say that, okay, this car class implements transporter. So it can have its own constructor, its own other methods. But we know that it should definitely implement the function that is coming from the transporter interface, which is this move function. So if we don't implement it, then we'll get an error and so on. And well, we can again, a car class it implements transporter. The bike class also implements transporter. So they can have all their different methods. Like this car has a drive, bike has a pedal method. But we will know that both will have this move function. Even though they are implemented differently, we will know that, okay, their signature is same, so I can call this move function for both of them. And I had already talked about this, but again, just to give one more example. So we can implement multiple interfaces. Let's say that we have, again, this transporter interface, and then this colorable interface in which it has these two functions. So if the car implements these two interfaces, then we have to also implement all of them, like move function, set color, and the get color functions. All of them should be implemented. This is just one more example about this, providing that one, so I will just skip this part. Now, this default interface methods, this is a relatively new topic for the interfaces, because when I was a student, this was not possible. Like in interfaces in earlier versions of Java, you were not able to define any methods. But then with the more recent versions of Java, now Java changed what is an interface, in which now we are able to define some functions in that one. And this is called the default methods. So for that one, we have to use this keyword default in the class definition. And then and then we will basically implement that function in the class. Sorry. So I will show it through the program also. So let's say that we have this payable method. Well, if I know how to calculate the amount, let's say, okay, I don't want to make it unimplemented. I just want to implement it within the interface. Then I will use this default as a keyword, and then I will just implement how it should be. Of course, there will be some code that we are not interested, and then since it's a float number, it should return some number. But in short, if you want to implement a function within an interface, you have to say that this is the default. What it means is it's still giving me error because of this public default part. I can override it, but if I don't override it, like if I just delete it now note that I'm not getting any error. Like it has two methods. It has two methods: pay and then calculate amount. But calculate amount is already implemented. So in a build function, it implements payable. I didn't implement the calculate amount. I just implemented pay one, and I'm not getting any error anymore because it's not implemented. I can override it. I can redefine how to calculate amount. But if I don't want to override it, then I can just use the one what is implemented here. Okay. So this is the default function, and another part that has also came with the recent. It's not very recent, of course, but in the other versions of the Java, now you can also implement static methods. So what I mean is you can basically define any static method in an interface, I don't know its content. If you whatever you would like to put a message here, any code, any message, how you implement this. But basically, yeah, we can define static functions in that. And then when we go to this payable function, maybe I can directly call them. Since they are static functions, I don't need to create any instance of it. So I can just use that function also. So in short, it wasn't the case previously. Like when I say previous, it's not like 1 or 2 years. When I was a student, it wasn't the case. I think it was perhaps Java 8. It comes with, but I'm not exactly sure about the version number. But now we are able to define non-static functions and also static functions. For the non-static ones, we should put this keyword default to define it. We can override this function, but if you don't override it, then the class that implements this interface will be able to run whatever implemented is in this interface. Any questions so far? No question? Okay. So, as a summary, what are the difference between abstract classes and interface, or what are the common points? Well, both cannot be instantiated. What it means is I cannot create an instance for an abstract class and also for an interface. So they have this common point. And in both of them, in an abstract class and interface, I can have unimplemented methods. In an abstract class, I'll call them abstract methods, but in an interface, I don't need to use this abstract keyword, but they are not implemented. And well, they can, but what they are also saying that, okay, if you extend an abstract class or if you implement an interface, you have to implement those methods. And also, in an abstract class, we have still this inheritance relationship. Like I can say an item is an abstract class and then book extends it. So there's a book is an item. There's an inheritance relationship. But in an interface, we don't have this. Like a bill is not a customer, is not an employee. They don't have this inheritance relationship, but they have a common point. Because they have a common function in most of the cases. That's why most of the interfaces have this verb in it, like comparable, payable, or so it just implements an action. It's not like an identity of that class, but it is both are payable, both are comparable. So that's why we usually use this kind of naming. And in an abstract class, we can only extend, due to the inheritance, we can extend only one, but in an inheritance, we can implement multiple interfaces. And in an abstract class, we can define constructors because they are eventually in an inheritance relationship. They have a relationship with an object, but in an interface, we don't have the constructors. We don't have the instance attributes. So this is the main difference. All right, I have 3 minutes. So in that one, I will ask you one question, and I will show it through my code. Yeah, I have this interface payable, okay? And then if I create an abstract class, which is, let's say, person, like an employee maybe, which implements payable, I will not finish my typing because Eclipse will give the answer to you. Will I be able to compile even though I don't put anything in this person code? So basically, will Java complain about it, why I didn't implement pay, function pay? That is in this payable interface.
It should not, because this is an abstract class. So we are expecting to extend another class to this person class.
Yes, exactly. So Java will not complain that, okay, it's that I didn't implement payable function even though I said that it implements payable. The reason is that, well, Java is a little bit patient in this sense. It is basically saying that I know that you cannot create an instance of a person. So which means you cannot run it. If you really want to do it, you need a real class, I don't know, let's say supervisor, that extends person. When I do it, now I will get an error. And the error is saying that, okay, now you have to implement this pay function. Because now you are claiming that this is a full class. You can create an instance of it. But there is a class, there is a function that has to be implemented, pay function. Now you have to implement it. Because there's an inheritance relationship between person. If person implements payable, it means that supervisor also implements payable. Because every class that it has should be also here. So when you say that, okay, add unimplemented methods, it will put this pay function. Yes, please.
So every class that extends person has to implement every class, or one of them should be.
If it's a concrete class, it should. But if, let's say that we have another class, super duper visor, okay, which extends our supervisor, yeah, then it doesn't have to implement this one because it is already implemented. But if it implements our person, sorry, oops, then it has to implement, because now it's a concrete class, it directly extends the person, so it has to implement it. But if I'm saying that, okay, you know what, this is also an abstract class, man. If I say this, then it will not complain about it again. Because this is an abstract class that extends an abstract class that implements an interface. Then Java will say, okay, still not a concrete class, so no worries, you can continue until you end up with a concrete class. You don't have to implement it. All right, it's 2:51, so I think I should stop here. Thank you for your attendance. This is the class for today, and we finished the chapter inheritance. Next class, we will start with the file reading.